So this is really very difficult. Now, finally, let me also, already actually I've spoken about this, but let me explain to you again how we get to general relativity from the single monad model of the cosmos. Because we have seen so far that Lorentz factor, we can derive it from the basic equations, and we can derive the proper time, and we will see how to derive, for example, the mass energy equivalence in many ways now. Therefore, if we suppose that this is really a better, higher theory of than general relativity, then of course general relativity must be obtained from this theory at a certain condition. Just like, for example, special relativity is obtained when we ignore gravity, and classical mechanics is obtained when we ignore the relative velocities. So this is called the correspondence principle. Any higher theory must contain in it the previous series. So now I am saying that the single monad and the duality of time theory automatically contains general relativity, and we get to general relativity when we approximate the outside motion, the apparent velocity, when we approximate it and we consider it all real. So if we suppose this is our world, if we suppose that all the points in our world are real, and therefore the motion is real, and therefore we have infinitesimal transmutation, then we get a positive value of velocity, and therefore we get a continuous space. This is not the reality. The reality is that these points are happening one by one, one at a time, and therefore we don't have, as we said many times now, we don't have real velocity, we don't have real motion, we have zero velocity at every point in time, but we are averaging this change, just like this point, this laser point is moving now. So when I move this here, it's actually the computer monitor is actually recreating this point at every new position. So at every moment of time, its velocity is zero. However, outsidely, we watch and we see some velocity and some continuity. So if you take the phenomenal level, you have continuous velocity, continuous space-time. If you take the reality, the metaphysical level, the monad level, the recreation at every point of time, of the real time, you have discrete points of view, discrete points of space, and zero velocity at every point. Only you have average velocity outside. So when you are averaging, you are getting to the general relativity. This approximation is automatically implicit in all our measurements and all our life, because we feel ourselves, we are being deceived, we are deceived, and we think that we exist in a real time, and therefore we think of the existence as being continuous and coexisting together. In reality, it exists only one point at a time, and therefore we have discreteness. So from here we get a special approximation for the general relativity, just like general relativity itself can be approximated to special, and the special can be approximated to the classical or Galilean relativity.